Here we have an open box problem. It says an open box, top open, is made from a rectangular material of dimensions A is equal to 9 by B is equal to 8 inches by cutting a square of side X at each corner and turning up the sides. See the figure. Determine the value of X that results in a box with the maximum volume. So first of all, let's think about what does it mean to be to have the volume of a box. The volume of a box would be the same as like a rectangular solid, which has a formula that the volume is equal to the length times the width times the height. So let's say, for example, we could call this side the length, this side the width, and if we just mark some dotted lines here to show if we cut out these blue squares, then we can fold up the sides on these dotted lines to make a box, and the box would have a height that's equal to X. So the height would be the value of X essentially. Okay, so the first question is asking us to express the volume V as a function of X. If the length is this side is the same as A, which A we know is 9 inches in total, but we're cutting out a piece length X here and a length of X here. So it'd be a length of 9 in total, but we have to subtract out 2 X's to give us this length without the part that gets folded up. So that's our value of L. To find W, it's a similar idea. We start with the full length, that is the length of B, which is 8. But we need to subtract out, we have an X that gets removed on this side, we have another X that gets removed on this side. So it'd be 8 minus 2X. And the height of the box we found before is the height that gets cut out, which is a value of X. So we can take this and put it in to express the volume as a function of X, because these are all the length times the width times the height. That gives us our volume of X. Excuse me, our volume as a function of X. The next part is asking us to determine the domain of the function of X, the function V of X. So we need to figure out what are all possible values of X. It wouldn't really make sense to have X to be, like to think about the smallest value of X that makes sense. It doesn't really make sense to have X be 0, because then we wouldn't be cutting out any square and we wouldn't be folding up anything. But technically we could have like a 0 volume. So let's start with the smallest would be a value of 0 for X. And then the largest value, if X, remember that this side is 9 minus 2X. So if X were up to 4.5, if X were up to 4.5, it would be this entire side. So it can't be any bigger than 4.5. But on the B side, this side is 8. So if the X, like if this X were 4 and this X were 4, that would take up the whole side here. So on the B side, the X can't be any larger than 4. So we take the smaller of the two values, and X can't be any bigger than 4, or that makes a 0 volume, because then we would have cut the entire side out. Okay, that gave us our domain of our function. The last question for this video is to expand the function V for easier differentiation. Let's first take this function. I'll distribute our X into the 8 minus 2X. When you have two set of parentheses next to each other, you do want to multiply but you only need to multiply by one at a time. So let's bring down the 9 minus 2x, and I'll distribute in the x into the 8 minus 2x, which makes 8x minus 2x squared. Now that we've gotten it down to 2 parentheses, we can use FOIL, and 9 times 8 is 72, so 72x, then 9 times negative 2x squared is negative 18x squared. Then we have another negative 18, sorry, that's not 18, that's 16, negative 16x squared, and then a plus 2 times 2 is 4, and x times x squared is x cubed. So writing this, combining our like terms and putting our highest degree term first, would be 4x cubed minus 8 and 6, just to make sure. Is negative 34x squared, and then plus 72x. That's fully expanded out. So we can put that 4x cubed minus 34x squared plus 72x. And that would be our expanded function. To continue this problem, I'm going to stop the video here and continue on the next video. So please join me on the next video if you would like to see the conclusion of this problem. And feel free to leave comments if you have any questions about this problem or another homework problem you would like to see a video on. And subscribe to my channel if you'd like to see more videos. Thanks.